Welcome everybody. This briefing is going to serve as a total revision for everyone that had offered Chem 205. Alright, so we started with the first experiment, test for alcohols. We were able to investigate on how unknown samples could be tested for the presence of an alcohol. And of course, alcohols are organic compounds identified by the presence of the OH group, which defines their functionality. That is the hydroxy group. It tells you about their reactivity, so it's important. And then this experiment actually shed insight into differentiating between primary, secondary, and tertiary alcohols by employing several tests. So you were requested to carry out 2 out of these tests, but then you are not supposed to exclude the knowledge derivable from all of these tests. So you are presented with the acetyl chloride test. Acetyl chloride, all right, it's a reagent. I believe you should know what acetyl chloride is and how to write the functional, the chemical formula, right? So you should know what an acetyl chloride is, and then that's a test anyways. Then you were also able to carry out the Lucas test. Yeah, you should also know what Lucas reagent is all about, So, and you were also the third experiment, the third test, which is the chromic acid test. Don't forget, the chromic acid test is also known as the Jones oxidation test. All right, but then specifically the acetyl chloride test identified that an unknown sample could be an alcohol. All right, generally we use the acetyl chloride test to detect for the presence of an alcohol irrespective of the class to which this alcohol belongs. All right, so it does not have to differentiate, so it tells you. And then you can actually determine this by the evolution of heat and hydrochloric acid, evolution of heat and hydrochloric acid gas. That tells you for the presence of a hydroxy group, which is the OH, in the unknown sample. The chromic acid test, which I've said earlier, is the Jones oxidation test. On the other hand, it could differentiate between a primary and secondary alcohol only. So that means it does not account for the presence of a tertiary alcohol, right? So that's because tertiary alcohols do not react, with the chromic acid reagent, with the chromic acid itself, and that means they don't get oxidized, all right, by the chromic acid reagent, because the chromic acid is an oxidizing agent. Okay. So, and this is because the tertiary alcohol that do not react is just because the absence of hydrogen atom on the carbon atom bonded to the hydroxy group. And it's also due to the fact that there is some degree of steric hindrance that is disallowing the reaction between a tertiary alcohol and the chromic acid, that is the Jones oxidation test. All right, so but then the primary and secondary alcohols are oxidized. They are readily oxidized by the chromic acid reagent, right? So, and the oxidized primary alcohols are oxidized to aldehyde, and the secondary alcohols are oxidized to ketones. All right, so once this oxidation of the primary and secondary alcohols occur, it's just generally due to the removal of the hydrogen atom, because there's a hydrogen atom that can be removed from the carbon atom bonded to the hydroxy group in the primary and secondary alcohol, due to the presence of that hydrogen atom that is being removed, and that leads to the formation of a carbonyl compound. A carbonyl compound is a carbon double bond oxygen kind of relationship, and that is present in the aldehyde that is formed from the primary alcohol and in the ketone that is formed from the secondary alcohol. All right. So in turn, the primary and secondary alcohols are able to reduce once the chromic reagent is oxidizing aldehyde ketones but not tertiary. All right, the primary and secondary alcohol do something in return. They tend to reduce the chromic acid reagent from the +6 oxidation state to the +3 oxidation state. +6 oxidation state of the chromic acid reagent is orange in color. So in the presence of the primary or secondary alcohol, the chromic acid reagent is reduced to a blue-green precipitate from the initial orange color, and that is characteristic of the primary and secondary alcohol being able to reduce the chromic acid reagent. All right. So you were able to carry out the Lucas reagent test. That's Lucas test, right? Actual Lucas reagent is a mixture of zinc chloride and hydrochloric acid. You're supposed to know that too. And why do we use Lucas reagent? We actually employ this to identify, or let's say to differentiate rather, between a primary, secondary, or tertiary alcohol. That is what the Lucas reagent does, right? Whereas the chromic acid, as Jones oxidation state, can only differentiate between primary and secondary, but not tertiary, right? And acetyl chloride test only identifies that an alcohol is present, but it does not tell you if it is primary, secondary, or tertiary, right? So in the Lucas test, all right, the zinc chloride serves as what's it called? A catalyst. Let's say a Lewis acid catalyst. Remember, the Lucas reagent is a mixture of zinc chloride and HCl, right? So the zinc chloride serves as an acid catalyst. That is Lewis acid catalyst. While the hydrochloric acid itself provides an acidic environment for the reaction to take place, all right, for the determination. Now, it has been established that the tertiary alcohols react faster, all right, and possess more stable carbonium ion, all right, that is being formed. So the tertiary alcohols react faster with the Lucas reagent, right, while the primary alcohol does not react under normal conditions. So they probably need to be heated before they tend to react. They are very slow, all right. So, and the stability of their carbonium ion, the tertiary is more stable. It forms a more stable carbonium ion than the secondary, and the secondary forms more stable carbonium ion than the primary. Now, to actually observe the reaction, there is just but a formation of cloudiness upon the addition of Lucas reagent. All right, that is characteristic of this test. So the formation of cloudiness, the ease to which this cloudiness is formed. There is usually an immediate cloudiness for tertiary alcohols. You know, they form immediate cloudiness. And secondary tends to form at a slower rate, and primary does not under normal conditions. All right, so that was just experiment 1 and a brief summary of experiment 1. And then in the experiment 2, that was supposed to be preparation of ethene by dehydration of ethanol. All right, so you're supposed to know the chemistry behind that. We can't just say we want to prepare a gas, or produce a gas from ethanol by dehydration without knowing the equation of reaction. So what is dehydration? Removal of water. All right, so now this experiment was aimed at producing ethene gas, all right, by heating the sample of ethanol, right? Heating the sample of ethanol using sulfuric acid. The sulfuric acid actually served as catalyst to produce the ethene gas, all right, and remove the water. Dehydration, removal of water is dehydration, right? So, and the gas was supposed to have been collected, or was collected by a method we call upward displacement. That is collecting the gas over water. And why do we collect the gas over water? Why is ethene gas collected over water? And that is because it is less dense than water. All right. So basically, you're supposed to know the chemistry behind this experiment and definitely equation of reaction and all of that. All right. This is just but a brief summary of experiment 2. Then experiment 3 had to do with phenyl benzoate. All right, preparation of phenyl benzoate by discarding Bowman's method. Discarding Bowman's method is just but in the previous videos I think I've explained that it's a benzoylation reaction where a weighed mass of phenol, all right, phenyl benzoate is derived from phenol. So a weighed mass of phenol reacts with benzoyl chloride, and that is where the name benzoate is coming from, and that is why I said it is a benzoylation reaction. So a weighed mass of phenol reacts with benzoyl chloride in the presence of sodium hydroxide, which is a base, all right, to form phenyl benzoate. From here you can actually derive the equation of reaction 2. So essentially the sodium hydroxide serves to activate the phenol. All right, now once the phenol is activated, it forms what is called a phenoxide ion. Right, sodium hydroxide reacts with the phenol to form the phenoxide ion, all right, or the sodium phenoxide, all right, which is a very more reactive nucleophile. All right, so the base provides an avenue of converting the phenol into a reactive nucleophile, right? And we know what nucleophiles are, right? They're electron-rich centers. They can actually donate electron, go into reaction, and form a bond. All right. So once this reactive nucleophile is formed, which is the phenoxide ion, the benzoyl chloride is then added. All right, which reacts with the phenoxide ion, right, to form what is called the phenyl benzoate, and releasing sodium chloride. Where is the sodium coming from? Yes, exactly, from the sodium hydroxide. Where is the chlorine coming from? Exactly, from the benzoyl chloride. All right, so that is essentially this, and you expected to determine the melting point and all of that. All right, so that was just experiment 3. Now for experiment 4, that was supposed to be the preparation of the derivative of aldehyde and ketone, right? And this experiment was dependent upon the presence of carbonyl group. We've mentioned carbonyl group. Without the presence of the carbonyl group in the aldehyde and in the ketone, if you remembered the oxidation test, the Jones oxidation test to determine the presence of the primary and secondary alcohol had to do with the oxidation of the primary alcohol to aldehyde, secondary alcohol to ketone, okay, due to what? Forming what is called the carbonyl group. All right, so this experiment, preparation of derivative of aldehyde and ketone, which is the 4th experiment, was dependent upon the presence of carbonyl group in the aldehyde and in the ketone. Okay. Now, these aldehyde and ketones actually react with the derivative of ammonia. What is a derivative? Derived from ammonia, all right? And that derivative is called 2,4-dinitrophenyl hydrazine, and that is also called, the code name is Brady's reagent, okay? So, and that is the derivative of ammonia that reacts with an aldehyde or a ketone possessing the carbonyl group. The ketone and aldehyde possess the carbonyl group. So essentially the reaction is between the Brady's reagent, which is the 2,4-dinitrophenyl hydrazine, with an aldehyde or with a ketone, whichever be the sample that was given. All right, now the product is called an imine. Hydrazone is an example of an imine. So once this aldehyde containing, or the ketone containing the carbonyl group, reacts with the Brady's reagent, 2,4-dinitrophenyl hydrazone is formed, which is an imine. Imines are identified by the carbon double nitrogen bond. All right, the carbon to nitrogen bond, but the double bond, right? So now this product is 2,4-dinitrophenyl hydrazone on reacting with the carbonyl group of the aldehyde and the ketone. And that is just the formula, that is just the chemical reaction that happens. All right, so essentially you are supposed to carry out these steps, follow them orderly to arrive at a very much conclusion. Now the 2,4-dinitrophenyl hydrazone that is formed is precipitated as reddish crystals. You see it appearing as reddish crystals, telling you that you've actually prepared the derivative, all right, of aldehyde and ketone. All right, so now, which is what? 2,4-dinitrophenyl hydrazone. Now experiment 5 had to do with the separation of compounds of coffee using thin layer chromatography. All right, so in that experiment you were exposed to the TLC technique of separation of compounds in a mixture by method of spotting. All right, and the development of capillary action. Capillary action means the movement of the solute particles or the components of the compound or mixture up the TLC plate using a solvent system. And the solvent system, the mobile phase that was employed was N-hexane and ethyl acetate mixture, right? Now the components of the mixture itself was actually separated, based on their affinities. For the stationary phase, which we call the adsorbent, which in this case was the silico gel. Remember, the TLC plate is coated with whitish substances. That is the solid phase, that is the stationary phase, and that is silico gel. All right, the components of the mixture are actually separated based on their affinities for the stationary phase and the solvent system, which is the mobile phase. And we've talked about the solvent system, which is N-hexane and ethyl acetate. So some of the components of the mixture have high affinity to the solvent, and you see them rising higher above, at the closer to the solvent front. Okay, while those that have more affinity to the stationary phase are not eluded as much as the other ones. All right, so it's just based on the affinities of the components of the mixture for the stationary phase and the mobile phase. All right, now you're also required to determine the retention factor of the separated component mixture identified as spots on the TLC plate by taking advantages of the distance moved by the sample components up the TLC plate. It is of very much importance you know how to determine correctly the retention factor for a given sample using a TLC plate. Now, why do we need the retention factor anyways? The retention factor helps you to identify the unknown compounds, all right, while comparing the values you've gotten to known retention factor standards or values. So if, for example, you got a retention factor of 2.6, so you compare that to already known values of retention factors for different compounds or components. Okay, and that will help to identify what spot or what compound has that retention factor. And then the retention factor also helps to ascertain the efficiency of the separation. Now this is just but a brief summary of the practical so far, but then you also expected to know all of this and how these things were done. What is it called? Equation of reactions. Any reagents, know what they are, because you can't just name a reagent and you don't even know how to write the chemical formula for that reagent. That is the chemistry behind everything. So take every note seriously and take your notes and prepare very much for your exams. Good luck.